Okay, so today I will explain, maybe I will introduce the ScalikeJDBC and also Skinny ORM, the both libraries. I created both libraries. Recently, I have so many contributors. I'm a founder of the libraries. So if you have any questions or comments about my library, feel free to ask me questions or give me some comments. And there's so many slides. So I direct that this is a tab of content. I will explain ScalikeJDBC first. After that, I will introduce Skinny ORM as well. Okay, so first of all, what is the ScalikeJDBC? And ScalikeJDBC is a tidy SQL-based database access library for Scala developers. Basically, the library is a thin wrapper of JDBC APIs. So you can use the library with any JDBC library, JDBC drivers like MySQL JDBC driver, Postgres, Oracle, whatever. So recently, not only RDBMS, but also other data store supports JDBC APIs like Presto from Facebook or Redshift also provides JDBC driver. So you can use it with ScalikeJDBC as well. But anyway, so what the SQL-based means? So the ScalikeJDBC is, as I mentioned, ScalikeJDBC is a thin wrapper of JDBC API. So as you may know, the JDBC is very low-level SQL API to talk with our database server. So the SQL-based database, SQL-based library means that basically that provides some ways to write SQL directly. There's two ways to do that. The first one is the SQL interpolation. So do you know the string interpolation? By the way, do you new to Scala, or are you new to Scala, or you know the Scala already a lot? Sorry, yeah, I can hear you.
Awesome. Well, as for me, I'm not been kind of new to Scala, but having just kind of background in Java Enterprise, so Enterprise Java. So I'm work a lot with GPA and so on. So I'm excited about the JDBC itself. So it is really interesting how it does. What was your idea and the approach to work with JDBCs for the side of Scala, and was that story with so-called async JDBC driver Postgres or something like that, which your library depends on. So, but that is interesting.
Yeah. Okay. So you already understand the JDBC and also the other Java libraries. So okay, I understand.
Yeah.
So do you know the difference between the SQL interpolation and also the very simple string interpolation? So okay, let me explain the difference. So the SQL interpolation provided by ScalikeJDBC is more powerful than just embedding the value into string. So because the SQL interpolation generates prepared statement object internally, not the string value. So as far as you use the ScalikeJDBC's SQL interpolation, you can it will be guaranteed to use the prepared statement for all the queries. So it's very safe in terms of SQL injection security. So that's a very important part of. And basically the SQL interpolation is the basis of the ScalikeJDBC, and the ScalikeJDBC also provides other way to construct the object. That is a query as well. Basically the query is kind of the method chain. It's more type-safe way to build the string interpolation object. And let me go through the concept. The next slide is the core concept of ScalikeJDBC. There's four factors. The first one is why the name is ScalikeJDBC. It's actually very obvious, but Scalike is a Scala-like. So I named ScalikeJDBC. I hope the library should be the idiomatic in Scala and also least surprise for Scala developers. So it's just Scala-like. The name shows the library should be the idiomatic, and it's a very straightforward way to do the database query in Scala. The next one is a no steep learning curve. So as I mentioned, the ScalikeJDBC is a very thin wrapper of JDBC. So you don't need to understand a lot of things rather than except for JDBC basics. So it's pretty easy to start using it. And also you don't need to be an expert at Scala programming language. You don't need to understand so many areas of Scala language. Actually, the Scala language has a lot of features, but you don't need to understand it, all the things. You don't need to understand, you need to understand just the string interpolation and also the very basic syntax. It's very easy. And also you don't need to understand other major libraries when you use just ScalikeJDBC. That means you don't need to understand Scala Z or cat when you start using ScalikeJDBC. And also you don't need to be an expert at functional programming so far. And the other important philosophy is I want to keep the library very practical, practical enough to deal with real situations. So I give highest priority on the backward compatibility among the patch releases and the minor releases. When I have to introduce some breaking changes to the library, I will upgrade, I will bump the major version, and I will provide some transition period for the existing users. So basically, I never introduced let's say breaking changes to the library yet. And also other things I will explain that later, but the multiple data sources are of course supported, and logging and unit testing support. I will explain later on the slides. And the library is also very handy. The library provides the Play framework integration and also source code generator. I will explain it later. So let's get started. This is the example code to initialize the connection pool. It's pretty simple. So the yellow one is how to set up the default connection pool. The connection pool.singleton and just the JDBC URL, the user and the password. And also you have other settings you can pass as well. And after setting up, after call the singleton method, you can use the connection pool already. So the next line is a connection pool borrow. You can acquire Java SQL connection pool connection object from the borrow method. And of course, in that case, you need to close it by yourself. But the next one is db.read-only. So the db object is corresponding to the default connection pool, the singleton connection pool. So if you have only one single if you have only a single data source in your application, you just need to use the connection pool, the singleton connection pool, and also db object. And the green one is the second, the connection pool. If you have multiple connection pool, multiple data source, in that case, you need to give some name to each connection pool. In this case, the secondary is the name of the connection pool, and this example code should use the symbol value for the name. Actually, you can use anything for the connection pool name. So not only symbol, but also string or integer or whatever. But the preferable way to do that is a single symbol name, symbol object in this library. But in practice, you can use other things or whatever. And by default, the library provides the Commons DBC2 connection pool implementation connection. By default, the library chose the Commons DBCP2 as the default implementation of the connection pool. But you can use other solutions like Hikari CP or CCPO or other things. So if you are interested in how to configure other connection pool implementation, check the official website later. And after setting up the connection pool, you need to understand how to use the DB session object. In this slide, the green part is the example to use the DB session API directly. The DB session APIs, the DB sessions API is quite similar to the Twitter's query library. I started the ScalikeJDBC project 7 years ago. At the time, the Twitter's query loss is a little bit, famous among the Scala engineers because there's not so many. At the time, there were not so many database libraries yet, and of course, the query loss was from Twitter, so it was very popular, and I was very interested in it. But actually, query loss supported only MySQL because Twitter used only MySQL at the time. So I was not able to use the library for my production systems because I had to access Postgres and also Oracle. So I decided to create my own one. That's the beginning of the ScalikeJDBC. But anyway, I was very, I agreed the design of the query loss. So basically, I follow the same concept with the library. After that, I implemented the SQL interpretation upon the DB session API. So the green one is a very primitive layer of the ScalikeJDBC, but recently the yellow one, the DB API is the standard way to use the DB session. So the SQL, the single or list specifies how to resolve the result, and the apply method actually issues the SQL queries. But the SQL object apply internally runs a DB session object method. In this case, single method will be called internally. And if there's no implicit DB sessions is available in this code, the code results in compilation error. It's not runtime error. So that's about the DB session. Basically, the DB session represents the Java SQL connection object and also handles the transaction. It's very simple. Okay. Yeah, the 11th slide is the example about transaction. So basically, the handling transaction is kind of handling transaction with ScalikeJDBC is quite similar to Rails ActiveRecord. Do you have any experience with Rails ActiveRecord?
Yes.
Yeah. So yeah, it's very similar to Rails ActiveRecord. So it's the db.localtx provides a transaction block. So the inside the block and also all the code use the shared implicit DB session object. In that case, all the operation will be executed in a single transaction. So ActiveRecord is actually, originally the ActiveRecord is a design pattern to how to communicate with database server, but Rails ActiveRecord is actually library name. So Ruby on Rails is, as you may know, Ruby on Rails is a full stack web application framework. Maybe it's the most famous web framework all over the world. But the part of the Ruby on Rails, the ActiveRecord is a part of the Ruby on Rails, and it's the OR mapper in Ruby. And I will explain about Skinny ORM later, but the Skinny ORM is so highly inspired by Ruby on Rails ActiveRecord. Okay, so next is SQL syntax. I explained about SQL interpolation in first slide. Yeah, so this one. So in this case, SQL and the string is a complete SQL statement. But for some cases, of course we would like to let's say reuse the same part, like the same records or same table name or whatever. In that case, we can use SQL syntax. So the SQL syntax is a piece of the SQL object, which can be embedded as is into SQL object. So what I mean is there's the yellow one is a SQL syntax, and the green one is just string. So the SQL syntax object is quite different from any other object will be embedded into the SQL object, SQL interpolation. So in this case, the variable C, that is a SQL syntax, will be embedded as is. So as a result, select and count asterisk is not be embedded as a parameter. But the next one, the Bobby is a string. The Bobby will be embedded as a parameter, and also the embedding part will be replaced with a placeholder of the prepared statement. So that's the difference between the SQL syntax and the any other objects. And okay, so the next one is this is very important part. So the SQL syntax support. The SQL syntax support is a basic trait to when you define which is very necessary, which is very important when you define data access object with ScalikeJDBC. So in this example, group member is table, and the case class group member is data object. This is a kind of entity object to which represents a single table row of the table name, the group member. And the companion object, group member, is a data access object in this case. Actually, it's not necessary to define it as a companion. It's okay to have another name, but it's pretty easy to understand. Use the same name. So in this case, I chose the same name, and the data access object is defined as a companion. The SQL syntax supports provides many features to issue database queries, and there's several naming conventions by default. You can customize or you can configure overriding some APIs, but by default, the SQL syntax support converts the class name or company object name to the snake case name. So in this case, group member as a camel case will be converted as a group underscore member when resolving the table name. The column name is also the same. So the SQL syntax support automatically fetch the field name, which is listed in a primary constructor. In this case, ID and full name. But ID is actually very simple, but full name will be converted as full underscore name when resolving the column names. But of course, in that case, for some cases, it's a little bit inconvenient. So you can customize the rules. So this slide shows the example. So if the table is plural, you can specify the name directly, like group underscore member. And also you can customize the conventional rule of the field name, column names. So for example, if you don't need to have the underscore between the full and the name in the column name, you can specify this kind of map object to convert override the conversion rules. Okay. And after defining the case class, entity class, and also company object, this is how to use it. The other things you need to do when you fetch some data from database servers, issuing some SQL query, and also extracting some data from the result set. So this is the example which does it. But Before that, I'd like to explain about the difference between the result and the result name. It's a little bit complicated. So the first of all, in this source code example, let's see, member.syntax provides the m is a value of the member.syntax and also string m. The m is a syntax provider of ScalikeJDBC. Syntax provider provides some part of the sequence, the sequence statement. I will explain the details later. Then the syntax provider provides the several APIs. There's 3 types. The first one is simply returns some field names with the alias name. In this case, the alias name is m. And the results provide, the syntax provider provides the result provider. So you can fetch the result provider via m.result. And also result name provider, you can acquire the result name provider by calling the m.result name. So the difference between syntax provider, the result provider, the result name provider is the syntax provider just returns m.full_name. It's just the name of the column. But the m.result full name returns not only the column name but also the the part of the select statement. How to explain that? But yeah, so m.full_name adds fn_on_m. fn_on_m means it's a alias name for the fetched column. fn is a full and the name, the first character of full and the name. If there's several columns like full name and female name, in that case, the fn will be conflict. Can be a conflict. In that case, ScalikeJDBC converts fn1 and fn2 automatically. And _on_ is a default delimiter between the shortened name of the column and also the table alias name. So if the 4 character is too long for you, you can customize the delimiter by overriding some attribute. And the result name provider provides just the name, the alias of the column. So in this case, fm_on_m. So that's all rules you need to understand when you use this API. So when running the query, you need to use the syntax provider and the result provider. But when you extract some data from result set, you need to use result name provider because the result set allows you to fetch the data using the result name. It's a little bit difficult to explain in English for me, but do you understand it? Does it make sense? Okay. Okay. So I'd like to get back to the previous slide. Mm-hmm. So the company objects have a prime method which accepts the result name. So that's the reason why which the method accepts the result name. So the apply method is extractor of the result set. So the apply method just care about the result name. The slide is already published. So if you need more time to understand this one, check the slide later. And actually the result the syntax provider is implemented with the dynamic, which is quite similar to the method missing in Ruby. So of course it's not type safe, but ScalikeJDBC have implemented the macros which validate which check the validity of the dynamic method call. So this is an example of the comparison error by the macro. So if you make some mistake, if you make a mistake on the name of the full name field, like full name plus E, in that case, the compiler detects a typo, and the compiler will show you this kind of very gentle error message, like the full name is not found. Expected fields are ID, full name, and created at and deleted at. It's pretty easy to understand. The ScalikeJDBC provides this kind of comparison error messages in a macro. Okay, so that's so to understand ScalikeJDBC, you need to understand the SQL syntax support and also the rule of the let's say the syntax provider. Okay, the query DSL. This is an example of the query DSL. So the DSL, the internal DSL looks very similar to SQL. So it should be very intuitive for all of you. And also it's also possible to use this one with SQL interpolation, but the library also provides the 1-to-X API. That is very useful to resolve the one-to-many relationship or one-to-one relationship or many-to-one, the many-to-many. That will be very convenient. So in this case, the programmer table has some relationship with the company table and the skill table through the programmer skill table. So the programmer has the company, programmer belongs to a company, and the programmer has multiple skills. So in this case, the programmer and the company is already fetched in a one method, and the skills are resolved in a too many, and the map method attach the corrected the skills to a corresponding the programmer object. And also subqueries or paginations are supported. So actually, if you have the very complicated subqueries or very nested subqueries the multiple times in a single query, you should not use query DSL. You should write the plain SQL with the SQL interpolation. But if you have only one single subquery, that'll be very straightforward way, but it's not so complicated. The pagination. So fortunately recently, Oracle also supported limit and offset. But right, yeah. But maybe the meeting started 10 minutes later. But anyway, I will. And same as Rails ActiveRecord, Skinny ORM is basically designed to be convenient for the 80% of use cases. Mm-hmm. So for 80% of use cases, the Skinny ORM is pretty easy to handle the cases. But the rest of the cases, the 20%, it's a little bit, the code will be a little bit longer, but it's still very concise. But also, I like the practical libraries. So the Skinny ORM is flexible enough to deal with the rest of the cases, 20% of the cases. For example, JPA doesn't support the tables which doesn't have any primary keys, but the Skinny ORM allows us to query the query tables, very legacy tables which doesn't have any primary keys as well. And if you need to deal with very difficult situations or very inappropriate situations, the last resort for the corner cases will be just using the ScalikeJDBC for that. So ScalikeJDBC is very low level, so you can deal with most of the cases with it. So there's a sub example. This is the minimum example of Skinny ORM. So the member is the entity class, which represents database table law object, and the member object is data access object. In this case, Skinny CRUD mapper is a base trait. The Skinny CRUD mapper provides not only query APIs but also create, update, delete method. If you don't need to have create, update, delete, you can use the read-only mapper, right, named the Skinny mapper. The Skinny mapper is a subtype of SQL syntax support. So the Skinny mapper or Skinny ORM traits are basically Skinny SQL syntax support, but the thing supported by SQL syntax support is possible with Skinny traits as well. Okay, so now the Finder API is very easy to understand. So basically, all the APIs start with find. The find all or find all by some where condition, and count or count by where condition. Or if the table has a single primary key, you can call the find by ID primary key value. That will return all value. Yeah, so actually it's very simple. But for most cases, but for some cases, the querying APIs are more powerful. So actually, the same thing can be done by Find API or querying API. So it's just kind of your take. Either you can choose you can of them, but querying API is like where that's very similar to where the condition by blah blah blah. So it's very similar to Rails ActiveRecord, and that's a bit to understand. But don't forget call end with the querying API. It's a difference between the Rails ActiveRecord and Skinny ORM. So as you may know, Rails ActiveRecord automatically detects what to do. So the Rails ActiveRecord response, the return value can be a correction object, but sometimes still not every but it's also in a statically typed log. Yeah, so that's the difference between the Rails and the Skinny ORM. Next one is associations. Sorry, my son interrupted me. And okay, so associations, of course, it's a relational database. So we need to handle the associations between the tables. In this example, the member belongs to a company. So this is a belongs to relationship. And there's a naming. If this company ID is the field name, and also company underscore ID is a table column name as a foreign key, or yeah. So if the name is the class name with the primary name, in that case, very simple. Just use the belongs to. It's very simple. But the column is a little different from the rule, or the class name or table is a little bit complicated. In that case, you need to use other APIs like belongs to with FK, or belongs to with join condition, or belongs to with blah blah blah. But for most cases, you can use just belongs to, or has many, or has one. It's very simple. So after defining the association relationship, the definition of the relationships, you can use it with the joins method. So like the member.joins with the company left, the find all by blah blah blah, or where the apply. The response is a sequence object, but each entity should have the company field. That should be some. And the last one is the insert, update, and delete. So there's nothing special about the create with attribute, or create with named values, or update by with attributes, or delete by some condition. Yeah, that's it. So maybe there's no, maybe you don't have any questions about how to use it. This is a brief introduction about ScalikeJDBC. So do you have any questions?
Well, I might guess you can explain for people which would watch this video about your vision about maintaining contribution. What are your plans? Maybe some specific features you are planning and to add. Maybe something. How do you manage proposals like which come from the features and capabilities of Scala, which might be used? How do you plan to manage proposals on features, and basically how are you going to maybe change in what would be the form of the supported circle as well? So from the end users which contribute through bug reporting, testing, and so on. How do you plan to? What's your vision for the upcoming few months, or maybe next year? Because I do have a person which say works in Germany, and he claims that his team accidentally received ScalikeJDBC related projects. So there's already something implemented for business intelligence that is somehow uses somewhat recent version of ScalikeJDBC. So maybe they them and other teams within other projects might be end user developers might be interested to contribute. So what's your basic vision? What's your detailed visions? How could we help to be involved, committing, and so on?
Of course, the project is open source, and also I believe that I myself is very open-minded to this proposal or contribution. So yeah, it's very helpful to hear if you or anyone give me some feedback about my library or some proposal about the implementation or specification. But I think I'm not sure what to say. So the ScalikeJDBC is very simple and very low level. So I don't think there are not so many discussion points about the library already, because the library has the 7-year history already. So I believe that it's very stable, and basically I don't have any plan to bring some big changes to the library. But I of course I promise I will keep maintaining the library for the in the future. But the one thing one important policy I have will be the basically ScalikeJDBC won't let's say merge the let's say some proprietary database specific features into the core part, like because we don't have any testing environment with Teradata or Oracle database. So officially the ScalikeJDBC supports only MySQL, Postgres, and H2. I forgot. So it's quite limited officially, but I of course I will merge any changes to deal with a real situation with Oracle database or SQL server, but officially we cannot guarantee the quality for that because we don't have any CI environment for that. So that's only one limitation, one policy about the contribution. But basically, I look forward to so many contributions from all over the world. And I saw the several questions from the chat.
Yeah, Yaroslav is asking something, so you could answer.
Yeah, 1 minute. Sorry. The first question is, do you support Scala 3? Yeah, that's a very good question. So actually, as you know, the .t compiler will be merged in Scala 3, and the existing open source libraries need to migrate its macro implementation. So how to migrate existing macro to the Scala 3 is not clear yet. The macro teams, the Scala core team is still working on the migration plan and also implementation. So I check the updates sometimes, but I'm still not sure yet. But I believe that there's they will show the appropriate way to migrate existing implementation. But if the Scala 3 drops the support for macros at all, I don't think so. But it's pretty hard to migrate the existing macro-based features to Scala 3 would be possible, but it's not a problem only for the ScalikeJDBC. There's so many libraries will be affected that, so that won't be happen. That so that of course I will support Scala 3, but regarding macros, the situation is still unclear. And Scala 2.13 collection will be changed. Yeah. So one of the core maintainers are working on the changes recently. So already the latest revision of Scala, the master branch, works with Scala Scala 2.13 milestone 4 release. So we are working on it already. And there's no breakages for existing users. Actually, the binary compatibility won't be guaranteed, of course, but the source code compatibility will be kept. The last one is, we are already working on it. But basically, the ScalikeJDBC only depends on the traversal ones before. We are going to migrate to use the iterator instead. That will be a very straightforward way to migrate from the existing one. But there's no so many dependencies with the collection APIs for us. So that's the only point we need to work on.